number of 60 by 60 product, but not panel at this time. It's a luminaire where the LED products will be on the top of the luminaire at the center. And you can see the distribution, luminous distribution of this one with comparison to the previous one. This is more controlled, and this has more luminous intensity here under the luminaire at gamma 0. So this luminaire consumes 27 watt and produces 2700 lumens. And as you can see here, and this is categorized UGR less than 19. So this, before you use that, you will be sure that this will give you a low UGR rating. And these are the result. UGR less than 17. By the way, the previous case, the UGR obtained was 22, which is a higher glare rating, higher than what the standards say. And the total power of this is 432. This gives 5.4 watts per square meter. And it achieves 500 lux, and this saves 30% compared to the base case. All right, now this option, I will be following what the standards say. Remember, I told you that the 500 lux should be only on the task, where the task is the workstation. So these workstations here, I will be having the 500 lux, okay, and these workstations. So what I do, I will be using again 16 numbers of the downlights, but this downlights is each one is 9 watt with the lumens of about 1,200 lumens to have a general overall illuminance all over the office space of 200 to 250 lux. And I will be using a task luminaire located at the center of each workstation. And this task luminaire will be pendant located, installed at about 1 meter above the desk level. And the power of this task luminaire is just 24 watts. So with this setup, I will be again achieving the 500 lux in the task on the disk itself. Total power is 261. LPD light power density just 3.2 watts per square meter, and a UGR of less than 20, which is again tolerable, close to 19. And what I'm saving 58% compared to the base case. Now we go further. So again, the same, the last scenario where I use downlights and pendant light over each desk. Now, during the day, of course, let's say during the lunch break, when people go out, okay, if we are not implementing daylight, motion sensors or occupancy sensors, the lights will be on even when there is nobody using the space or even sitting on the desk. So what is recommended here, what we are recommending, is that the luminaires, which is the pendant ones, the task luminaires, if we integrate a small motion sensor, represents detector, which detects the presence of the guy sitting on the desk. When he's not there, this pendant light will go off. So in this scenario, if there are only 2 guys occupying their workstation, the power will reduce to 190 watts, and the light power density of 2.3 watts per square meter only, and that will achieve 70% saving compared to the base case. Okay, energy efficiency recommendation. Energy efficiency is an important topic which is covered by all the lighting standards, where they give the limits for the light power densities, which is watts per square meter per application, where or any lighting designer, anybody who has designed any application, it's not enough only to achieve the required lux level, whether it is 500 or 300, but also he has to look how much this lighting consumes energy. Now, these levels here was taken from the standard which was issued more than 10 years ago, where at that time LED was not revolutionized at that time. We're talking about conventional lighting. So for 500 lux, the maximum allowable light LPD was just 11 watts per square meter. But nowadays, with the LED revolutions, these numbers has reduced dramatically from 11, let's say, to 7 watts per square meter for LED. Again, to emphasize this table was taken from the American standard called ASHRAE, American Society of Heating and Refrigeration and Cooling, where also they give the limits for the light power density for different applications. In our case here, office, it says 0.65 watts per square feet, okay, which is equivalent to exactly 7 watts per square meter. Okay, you cannot have office lighting without proper lighting control. We've discussed about the motion sensor, occupancy sensors. Okay, we have to discuss also about the importance of daylight sensors. Daylight sensors, these sensors which senses the amount of daylight in any office space. And these daylight sensors will be connected to my luminaires. My luminaires will be having DALI drivers. So when there is enough sufficient daylight penetrating, so my lighting here, my luminaires will dim down to the required lux level. Okay. These are some important sayings about the importance of daylight by some international architects and designers. Daylight is not just only a free light, which we should utilize. Also, the existence of daylight in the office space is very important to improve the well-being, alertness, and mood. And also, it gives a very efficient work environment, improves the work efficiency. Okay, showing this example here, it's an office space where they have very large windows where daylight, a lot high amounts of daylight penetrating to the office space, which is good. But what's not good is that they did not benefit from the energy saving. You can see here the luminaires are on, where during the day there are no daylight sensors, and to maximize the energy saving from this situation. All right, I will be doing again some comparisons to show you the energy savings achieved if we implement the use of daylight sensors and controlled luminaires. Now, this is the base case where on the right-hand side of the office space, is glass windows, and there is plenty of daylight penetrating into my office space. But my luminaires, all the luminaires here are not daily controlled, so they will be on all the time with full power and full output. So the total power of this scenario here as the base case, 360 watt. Now, this scenario here, I will be considering implementation of daylight sensors. We can see here the red dots here, and they are installed very close to the glass windows. And I have the 4 rows of luminaires here. And the first scenario here, that the first row here will dim down to 25%. Second one will dim down to 50%, then 75%, then 100%. So with this scenario, the total power was 225 watt, and this will achieve 38% saving compared to the base case. We go further. During the day, more daylight is penetrating, and so the first row here of luminaires here will be completely off. Then this one will be dimmed down to 25%. This is 50%. This is 75%. So with this scenario, the total power will be 135 watts only, and this is achieving 62% compared to the base case. Okay, I will show you some lighting control scenes and scenario for a large office space where you see that we are utilizing motion sensors here, where whenever there are people, lights will go on. When people are not there, light will go off. See, and the catastrophe or the disaster when you have a large office space like this, and they don't have an automatic control, they have a manual control, and when everybody leaves the office and nobody switch off the lighting, all the lighting will be on throughout the night, and it will be a total waste of energy. So as a simple tip here, what can be done for large office spaces like this is to divide the ceiling into zones, and each zone maybe 5 by 5 meters. And in each zone there is a motion sensor. So if there are people in this zone, okay, lights will be on. No people in this zone, all the lights will go off. There will be saving energy with a minimum budget. All right, we talked about the quality of lighting. Now we talk about the quality of the LED product, of the products themselves. Okay, how do we measure the quality of the products? Of course, I mean by implementing the required standards, other than the IEC 60598, which talks about the general requirements of luminaires and particular requirements of luminaires, which is a safety standard, electrical safety standard. Now, this standard, which is also issued by SASU last year, it talked about the energy efficiency, functionality, and performance requirement, and also about the energy efficiency label requirements. These was extracted from the same standard. What the standard, the requirements of the standard, the type of test, energy efficiency, functionality, endurance, and the existence of hazardous substances limitation. And also here on the right-hand side, the measured parameters, which has to be measured and issued in the report. to get the